Specific energy is an amazing technology that addresses the issues with pumps and the use of pumps, pump failures, predictive maintenance, so that we don't have wastage when pumps go out or need to be replaced. And what I didn't know until I met his team was that situations like the hurricane in New Orleans, where the whole city was flooded, and an incident in King County across the coast of the Northwest here in the United States, were actually destroyed, not because of pollution problems or because of the extreme weather events, but because the pumps went down during those times. And if they knew and were able to maintain the pumps adequately, those areas could have been saved and could have endured through those storms. And so Matt's going to share with us about Specific Energy's role in helping utilities and addressing the energy needs, which we also know are even more important to address in India. And I will turn it over to you. But before I do, Hari or someone on the team, could you tell us what is the cost of a kilowatt hour today in India?
It will be about $0.01 of a dollar per unit of consumption. Great. Right?
Okay, about 13 cents. Or
so you worked it out, you know. What is it like there for you? If, let's say, at your home you want to pay for your electricity bill, how much do you pay per unit?
For us, we pay $0.1, so about 2/3 of what you pay.
$0.1, so you're paying about 10 cents.
You're
paying much the same as we do. Yeah.
And I just want to reiterate some of the unquantified, benefits of this, because we did work with, there are a few other similar technologies. And I think Chandra also mentioned that in the chat, so there are always competitors out there. If you have a marketplace, you want to know that there are other types of players that people could look at so that you can compare. But I think for those who are on this call who haven't looked at pumps yet, it's amazing how much maintenance there is, and what the utilities and others have to do is just send people out blindly to check on these things, not knowing when they're degrading unless they have something like this. So the savings on maintenance, being able to replace a person in the field and have these devices out in the field for you is pretty incredible. But your CapEx also, I believe you guys use other types of, you'll use other sensors. You do sort of the analytics box, correct? And not, could you explain that a little bit more, Matt? So it's clear,
sure.
Like who would be partners? Yeah,
absolutely. So at Specific Energy, we don't provide any of the field instruments. I mean, we would typically expect those instruments to be in place on a pump station anyway. Most pump stations will have some kind of suction level or pressure for pump protection, and they would mostly be monitoring discharge pressure and flow anyway. So if we're going to retrofit onto an existing pump system, we would expect those instrumentation to be in place, and if they're not, we would ask the utility or their system integrator to provide them. And similarly, if we're going on to a new build pump station, we would, as part of our specification, tell the utility or tell our customer that those instrumentation need to be on there. But 99% of pump systems that we've been looking at have got some, if not all, of those pumps instrumentation in place, because they're pretty generic and pretty standard for pump protection.
Mm-hmm. And I'm aware there's someone else here online, Nick Polsinelli, who handles satellite communication. And maybe you could talk to the reliability of the pump system, like the type of communication system you use, because quite often the pumps fail when there are extreme weather events or when there are things that make communication more difficult. If you could comment on your preference.
Sure. So there's a couple of things there. So, I mean, firstly, as I mentioned, the DPO sits at the edge. So the DPO is hardwired to the PLC. So there's no communication issues other than hardware failure, either on the PLC side or the DPO side there, which is very, very infrequent, because both have UPS or battery backup. So in terms of the DPO not communicating with the PLC, that's very, very unlikely to happen. And we've built protocols in that if that does happen for, let's say a lightning strike or vandalism, something like that, then if the PLC is pre-programmed that if it loses signal from the DPO, then it reverts back to its original PID loop control. So that function is built in. If there is a failure or a loss of cellular communications, everything is still backed up on the DPO, and it's backed up at once per minute. So if there is a failure in cellular, then you're not losing any data per se, or you're losing it being backed up to the cloud. And when that communication is restored, the DPO automatically battery backs up to the cloud, so you have that data reinstalled. Now, as Mary mentioned, that should pump systems go down, or should they encounter some difficulties, which isn't uncommon during extreme weather events, the DPO, because it's cellular, we essentially operate as a backup cellular SCADA system. So we can then put everything back onto the cloud. So if there's a loss of any in situ field instruments, any traditional radio telemetry, we can back everything up onto our cellular telemetry and keep it operating. And we did that around this time last year during the deep freeze we had over in Texas. A lot of our utilities lost their pumps. They certainly lost their telemetry. So we were able to transport their operation to the cloud, use a cellular SCADA system and keep their system operating. Where they lost their pumps, we were also able to bring in diesel backup generators, and then we're able to use our digital twin to model what pumps and what speeds to operate at, to know how long they had in terms of diesel supply, so that we could make sure that they kept those pumps operating. We weren't using all the diesel before replacement could get there. So it's very much a kind of intuitive in situ modeling system for disaster events, as well as kind of standard operation.